Today's class we are going to discuss about candidate elimination algorithm. Last class we have seen what is the drawback of finders and what is meant by version space and list then eliminate algorithm. That algorithm will be explained with the help of water sport game. Already we know that water sport game. Okay, so with that example, the version space and candidate list then elimination algorithm is explained. Now we are going to see the candidate elimination algorithm. So candidate elimination algorithm computes a Berson space containing all hypotheses from H that are consistent with an observed sequence of training example. So here main thing we should see the consistency. It should consistent. Consistent means that is H of x is equal to C of x. That is then only it is consistent. Satisfy that okay, already we have seen the difference between consistent and satisfies. H of x is equal to C of x. We will see that. So this is the algorithm, candidate elimination algorithm. First initialize D to the set of maximally general hypothesis in H. Okay, first G we are initializing to most maximally general hypothesis in H. That means general means all question marks. All attributes will take question mark. That means it can take any value. Then initialize S to the set of maximally specific hypothesis. That means all attributes will take the that is null value, that is pi. Okay. For each training example D, if D, the training example may be a positive or it may be a negative. If it is a positive, remove from G any hypothesis inconsistent with D. Already this one we have seen in the list and eliminate algorithm. So after seeing that positive example, we will check whether that is inconsistent with the hypothesis. This is the inconsistent means that will be removed. That will be removed from G. For each hypothesis S in capital S that is not consistent with D. S is most specific hypothesis. If that also it is not consistent with D, remove S from capital S. Add to S all minimal generalization H of S such that H is consistent with D and some member of G is more general than H. Yes, correct, no? Remove from S any hypothesis that is more general than another hypothesis in S. Okay, this is the for positive training example. Positive example means remove from G any hypothesis inconsistent with D, and for that S also we got for each and every step positive or negative we have to check with G and S both. Positive means we have to remove from G hypothesis inconsistency. If it is negative, remove from S any hypothesis inconsistent with D. That is the difference between positive and negative training example. Other concepts are almost similar. So now we'll see with the example. So there is a first step. We have to initialize S to more specific hypothesis, that is pi. G to G naught to more general hypothesis, all will take the value question mark. Any value it can take. Then first training example is positive. So what we are going to make? We are moving that S naught to is specific to more, that is S1. That is this moving from that is S1 is more the general than that is S naught. Okay, that is then S1 instead of pi it is taking the value sunny, warm, normal, strong, warm, same. Okay, then G1 will be as it is because S1 will consider for positive. Then for training example D, this is another one positive. So that S1 is already this one. Then S2 based on the thing sunny, sunny, sunny. Warm, warm, warm. High, normal. Can take the value high or normal, both. Any value. So question mark. Strong, strong. Warm, warm. Same, same. So there is no change. Then G2 it will come like that. G1 comma G2 will be same as it is, that any value it can take. Then next is negative training example. S, that is one. So negative means in that S specific hypothesis there is no change. It will be as it is. Then in general hypothesis, so that we have to check it. First is sunny. Sunny will be sunny. This we can take. Then other attributes can take any value. Then next we will take the next value warm. Then other attributes can take second. This is general and only warm value it will take. Then other things are general. Okay, next one we are taking next, all the values are the same, then only the last value is warm. So from this we are moving to the general. Okay, this is specific, general to specific. So here again the positive training example, then S only it will be specific hypothesis only it is considered. So we made the sunny, then here warm, then high question mark, it can take any value, so question mark. Then strong, it can take cool or warm, then question mark, change or same, question mark. Okay, so S4, G4 is same, that there we have seen, no, we'll check that with the this inconsistent, that should be eliminated over there. So see here, this is inconsistent with the example, so that will be eliminated. So only we are having these two. From the, that is, this is a G3, this will be eliminated and it will move to the G4. So now we'll take here, we are having S4, this is S4 we are having over here, then G4. From that S4 is moving towards the general, specific to general. Here from here we are moving from general to specific. Okay, so from here we are taking the sunny, then sunny will be there, then question mark, sunny, question mark, then it will come sunny, there is question mark, then strong it can take the value, then question mark, this one it will come, then along with that other attributes we have to check it, make it as a more general, then and so on. This is the thing. So the final version space for enjoy sport, concept learning problem and training example, this is the final version space. It includes specific hypothesis as well as general hypothesis. Here the main advantages, here it will be considered as both positive and negative training examples. It will be moved from specific to general, general to specific. That's the reason we have take initially S naught with all the pi values. It won't take any value that is specific. Then G naught to question mark, that indicate it can take any value. Okay, so that is here the main difference between finders and candidate is, finders will consider only negative positive training example. Here we are going to consider both positive and negative. There we will move from specific to general hypothesis. Here both it is happening, specific to general as well as general to specific. So this is the candidate elimination algorithm. I think now completely all you people understood about version space and candidate elimination algorithm. Okay, so the next class we will see how the inductive bias will be handled. That is the last topic in the first module. Okay, so this candidate elimination algorithm is your second lab program. So you can take any data set for this also, like finders algorithm. Okay, thank you.